Motion and forces. Forces are applied to you every day, and you apply forces to objects every day. A force is a push or pull applied to an object. Sometimes it is noticeable that a force has been applied, like if you were to kick a soccer ball into a goal. But other forces aren't as noticeable. For instance, are you aware of the force the floor exerts on your feet when you are walking? Can you feel the force of gravity pulling on your body? What about the forces happening inside your body? Every push, stretch, or bend results in a force being applied to something in your body. Forces can be balanced and unbalanced. Sometimes one might assume that if there was no motion on an object, then no force has been exerted on that object. For example, if there is a box sitting in the middle of the floor and two students push on it with equal force in opposite directions, then the box will not move. But this is because the forces are balanced, and this will end up with a net force of 0. When two or more forces act on an object at the same time, the force is combined to form the net force. The net force on the box was 0 in this example because the two forces cancel each other out. Forces on an object that are equal in size and opposite in direction are called balanced forces. Now, let's say a friend comes along and now two students are pushing on one side of the box and the same student is pushing in the opposite direction. A net force will occur in the direction of the larger force. And the students who push with the greater force will cause the box to move in the direction of that force. If the box moves in the direction of the larger force, then there is considered unbalanced forces. Now, if those same two students start pushing the box in the same direction, but there's no force in the opposite direction, that kid walks away, so the two friends are just pushing together, then their forces combine or add together. The net force on this box now is found by adding the two forces together. Do you ever try to take a running start and then slide across a wooden floor with your socks on? Well, what would happen if you didn't have your socks on? Well, you'd probably land on your face. And the reason that we like to have socks on when we like to slide across the floor is because we want to actually slide and not slip and fall over. The point of putting the socks on is you are reducing friction. Friction is the force that opposes the sliding motion of two surfaces that are touching each other. The amount of friction between the two surfaces, such as your socks and the wooden floor, depend on two factors: the kinds of surfaces and the force pressing those surfaces together. If you were to look at both surfaces of your socks and the wooden floor may seem smooth, but under a microscope, you would see these tiny, tiny bumps going across both surfaces called microwelds. The larger the force pushing the two surfaces together, the stronger the microwelds will be, because more of these little surface bumps will come into contact with each other. And to move one surface over the other, a force must be applied to break the microwelds. So in regards to running with your sock feet, we want to do the slide. But let's say now, if you want friction, like if you're trying to get away from somebody in tag, for example, now you want to take your socks off, because now we want that friction to stick around those corners and to move really quick so we don't get tagged. There are different types of friction. Static friction is the frictional force that prevents two surfaces from sliding past each other. For example, if you tried to push a refrigerator, your push would not be large enough to break the microwelds and the fridge would not move. However, if you were to have two friends help you and the three of you push that refrigerator, you would have enough force to break the microwelds between the floor and the bottom of the fridge. But if you were to all stop pushing, the fridge would quickly come to a stop. This is because as the refrigerator slides across the floor, another force, sliding friction, opposes the motion of the fridge. Sliding friction is the force that opposes the motion of two surfaces sliding past each other. Sliding friction is caused by microwells constantly breaking and then forming again as the refrigerator slides across the floor. So to keep the refrigerator moving, you must continually apply a force to overcome sliding friction. Now, add some wheels to that bottom of the refrigerator and it's a whole nother ball game. Rolling friction is the frictional force between a rolling object and the surface it rolls on. When an object moves through a fluid, which can either be a liquid or a gas, friction occurs along the surface of an object. There's a friction-like force called air resistance that opposes the motion of objects that move through the air. Air resistance causes objects to fall with different accelerations and different speeds. For example, take a flat sheet of paper and drop it towards the floor. The gravity acts on the piece of paper towards the floor, but the air resistance pushing in the opposite direction allows the paper to gently float to the floor. Now take that same piece of paper and crumple it up to a ball. Drop that crumpled paper to the floor. What do you notice? The downward force of gravity is still the same on the crumpled piece of paper, but the upward force of air resistance on the crumpled paper is less. Therefore, the downward force is greater and the crumpled piece of paper is able to fall faster.